We just described distributions with graphs. Now we are going to discuss distributions with numbers. The first is measuring the center of a distribution. We have basically two concepts. First one is called the mean. The second one is the median. The mean, sometimes also called the average. Suppose we have n numbers represented by x1, x2, x3, all the way to xn. The mean is calculated by first sum up all the numbers, then divided by the total number of the data, and represented by x bar. Mathematically, we can simply represent like this. X bar equals, this is called the summation. Summation xi, I is the subindex. Subscript I usually equals from 1 to all the way to the n. The summation of x all add up together. That means all these parts add up together. Then divided by the total number, which is n. We use this way to calculate the mean or the average. The median, represented by m, capital M, is the midpoint of a distribution. That means it is a number such that half of the observations are smaller than this, and half of the numbers are larger than this. So how to calculate a median? Basically, we have two steps. The first one is sort all observations. This part is different. When we calculate the mean, we don't need to sort the data. We just add everything together, then divided by the total number. That's it. For median, we need to stepwise sort all the observations, usually in the increasing order. So smaller on the left and the largest on the right. The second step is to find the middle point. The midpoint is the number that right in the middle. Now we have two situations. The first one is if the total number is odd, like for example, we have three numbers, so 1, 2, and 3. Then the middle one is just the second one. If the total number is even, for example, we have four numbers, 1, 2, 3, 4. Then what is the value in the middle? For example, here, if we have one. If we have one number here, 2, 3, 4. If we have only three numbers, then this one is right in the middle. If we have 4, which is even, then the median is the number that is right at this point, which is the mean of these 2 and 3. So we may represent this with math. So if n is odd, then in this case, if we suppose we have only 3, so n equals 3, then n plus 1 equals 4 divided by 2 equals 2. So we have 1 and 2 and 3. Then the capital M is 2. Is 2 here. If we have 4, if n equals 4 here, then because this is even, so half n equals 2 is this one here, and half n plus 1 equals 3, and the mean of these 2 is the mean. We have an example here. Suppose the numbers is let me see. If it was 5, 7, and 6. Suppose we have these four numbers, these three numbers. So which one is the median? the median, the first one, we need to sort this. So 5, 6, and 7. So this is 5, 6, and 7 sort into this. So because we have only 3 numbers, so the one right in the middle is 6. So the median is 6. Now, so this is this example. If we have, suppose we, let's continue this. If the total number is 4, we have another number here. We have 5, 8, 5, 7, and 6. What is the median? Again, step 1 is we need to sort this data 5, 6, 7, and the last one is 8 here. So now the total number is 4. So the median will be the mean of 4 divided by 2 equals 2. So x2. This is x2 here, and this one is x3. So the median will be the mean of 6 and 7, which equals which is 6.5. Right? So we can see 6.5 here is not even in the data, but it is the median of the data set. Right? So this is here. We discussed how to calculate the mean and how to calculate the median. So what's the difference? The median is a measure of a center that is resistant to skewness and outliers. The mean is not. What does that mean? That means if we have a data set, we can find the mean and the median. If we have an outlier, we add another one. Suppose the data is very big, then the median will not change a lot, but instead the mean may change a lot. For example, in US, we have a household income. The average is, I don't know exactly, suppose the mean equals, we just make some assumptions. Suppose the mean equals 40K, and the median, I don't know, equals suppose 41K. We just make some assumptions. Now, we assume Bill Gates is not included here. Now, Bill Gates has just joined this data set, and he has 100 billion. 100 billion, the average, we add Bill Gates, that means the total data will be added by 100 billion. Then divided by, okay, suppose this is average over each person. So the total population is about 300K, 300 million. So 100 billion divided by 300 million, that is like $330. So each one will be, the average will be added by $330. But the median does not change much. Why is this? Suppose this is the data set, and the lowest at this part, okay, the highest at this part. Suppose the median is here, so this is the capital M. Now, Bill Gates definitely at this part, and add him, we only add 1 to the total data set. So that means the median will move from here, okay, a little bit to the right, only by half person. Okay, it will be here. Definitely, we can see the median won't change a lot. But on the contrary, the mean will increase by 330. Right? So if we draw the distribution, this distribution is supposed to be like this. It's skewed to the right. So the median is resistant to the outliers. Right? For symmetric distributions, the mean equals the median. If the distribution looks like this, then the mean and the median both will be right in the middle. Right? So they are identical. But if the distribution is skewed to the, in this case, skewed to the left, because the left tail is much longer than the right tail, Now keep in mind, we just easy to memorize this one. The median is resistant to the skew. The mean is not. The mean is not. The mean is not, and the median is resistance. So that means if it is skewed to the left, then the mean will move to the left. And if the distribution is skewed to the right, the mean will will be shifted to the right. But on the contrary, the median will not change too much. So this is easy to memorize how the skewness and the outlier will change the mean and the median. In summary, the mean will not resistance to the skewness, but the median is. So usually the median, we use median to represent the center of a distribution. The next is describing distribution with numbers. We are going to measure the spread or variability. We just discussed the median. The median is also called 50%. As 50%, that means on the left-hand side it's 50%, on the right-hand side it's 50%. And we can have more concept. And the upper quartile is the median of the upper half. So suppose we have distribution. We have distribution like this. The capital M is here, it's 50%. Now this is the minimum. This is the maximum, and the M is here, and the lower part, and we have another median at this point. This is called the lower quartile, or we call it 25th. And for the upper halves, from median to the top, to the maximum, and this is half of the data, and also has a median. And this median is called the upper quartile, or 75%. We call this one as Q1, Q1. And we call this one as Q3. And this one we call the max, and we call this as the minimum. And this is the median. We define the difference between Q1 and Q3 as the interquartile range, IQR, and is defined by Q3 minus Q1. So the distance between Q1 and Q3, the absolute value. Or we can use Q3 minus. Usually the Q3 is bigger than Q1 because we sort this in increasing order. So Q3 minus Q1 will be a positive number, and which is defined by the IQR. We just discussed here 5 numbers for a given data set. The 5-number summary of a given data set is like this. The first one is the minimum. The second one is the Q1, and the next one is the median, and the next one is the Q3, and the next one, the last one, is the maximum. We can use, if we are given a data set, we can easily find these 5 numbers. This is called 5-number summary. Once we get these 5 numbers, we can use a box plot to represent this. Here we have an example. We are given a data set. We have 25 numbers. The number 1 is number 2, number 3, all the way up to 25. And we already sort these numbers. The smallest, which is indexed by 1, is 0.6. The second one is 1.2. The next one is 1.6. And all the way up to the maximum, which is number 25th is 6.1. To find the 5-number summary, we find the minimum, which equals 0.6. So the smallest equals the mean equals 0.6. The maximum is the largest equals 6.1. Then next we need to find the median. The median is right in the middle, because in this case we have 25 numbers. So the index, the 13th number, this 25 is an odd number, so 13th. Now on the bottom part we have a 12, on the top part we have another 12, and 13 is right in the middle. So definitely M equals median is 3.4 here. Then we need to find the Q1. Q1 is the median of the lower half. So here we need to be careful. The lower part, because 13 is the median, which is in the data set. So the lower portion will not include the 13. Instead, we have only 12. So from 1 to 12. For this half data set, the 12 is an odd number. So we do not have a number that is right in the middle. Instead, we have 6 here, and we have 7 here. So the Q1 will be the mean of 6 and 7. So which is the mean of 2.1 and 2.3. So 2.1 plus 2.3 equals 4.4, then divided by 2, which gives us 2.2. So this is the Q1. Same thing apply to the upper portion. The upper portion also have 12 numbers, not 13. Right? This one doesn't count. We have 12 numbers, so from 14 all the way to 25. 12 numbers, the 12 is even again, and we do not have a number right in the middle. Instead, we have a 2 in the middle. The first one is 19th, the second one is 20th. So Q3 is the average of 19th and 20th number, which is the mean of 4.2 and 4.5. So these two add up together, then divided by 2, give us a 4.35. This is Q3. Okay, now we have this 5 number summary, and we want to represent this with a box plot. The box plot is represented like this. We have a box here. The bottom part of the box represents Q1, and the top part of the box represents Q3. And somewhere in the middle, it's not necessarily right in the middle, but somewhere in the box, the number represents the median. And there's a tail here, and this represents the smallest number, the mean, and similar thing applied to the top. This part represents the maximum. So we have this one, this, and this. We have 5 represents the 5 number summary. This example is very typical. We have all 5 numbers distinct. For box plot, sometimes we may have all these 5 numbers are the same. So for example, if a data set equals all equals 1, that means the maximum is the minimum equals the median equals Q1 equals Q3. Then the box plot will be just a short line. We may not have this, we may not have this. This box may not exist. For example, Q1, Q3, and the median all the same. So anyway, if we are given the box plot, we may guess the distribution of the data. Last time we also discussed the outlier. Outlier is the number that far away from the distribution. And in this data set, if we use the graphs, we can find the distribution. But which one is the outlier? Usually, maybe the maximum or the larger numbers or the small numbers. So we have a rule to determine if a data is an outlier in the data set. The rule is called 1.5 IQR rules. The meaning is, so here we still use the same example to show how to find if there's any outlier. So here we changed a little bit of the data. All this part is the same compared to this, but the top part of the 25th, instead of 6. Okay, the last two is 5.6 and 6.1, but we changed here to 6.1 and 7.9. Then the box plot is this part the same, this is the same, and this is the same, this is still the same, and this part, the maximum will be 7.9, so we draw like this. So now we determine if there is any outlier. The IQR is the distance between Q1 to Q3. Q1 is here, which is 2.2. Q3 is here, is 4.35. So IQR is the length, is the height of the box. So IQR equals Q3 minus Q1 equals this minus this equals 2.15. How to determine if a data is outlier? The outlier may be in the lower part or maybe in the upper part, maybe both. So first one, we decide on the lower part. If a data is smaller than 1.5 IQR starting from Q3, then it can be considered as an outlier. So we start from Q1 here, and the length equals 2.15. 1.5 times this one equals let me see, supposed to be equals, do you have numbers here? Equals this one, 3.225. So 2.15 times 1.5 equals 3.225. Now we start from this point and we minus this 1.5 IQR, which is this. So this Q1 equals 2.2. This one minus 3 something must be equals negative. So any number that is less than, so let me draw this. Suppose we start from here, then we draw this. We draw all the way to here. So this part is 1.5 IQR. IQR means IQR is this. 1.5 is 50% longer than this. But we start from here up to all the way. Any number that's below this 1.5 IQR starting from here is considered as outlier. So in this case, this one is 2.2, this one equals 3.2 something minus give us negative number. So any number that is negative, smaller than this, will be considered as an outlier. In this example, we do not have any outlier on the bottom part. Now we consider on the top part, the same rules apply here. So 1.5, we need to start from this point and all the way up to somewhere, to, for example, here. This is 1.5 IQR here. So that is 4.35 plus 1.5 IQR, which equals this, and add up together this plus this, so it will be 7.5 something. 7.5 something is right here, but this number, the first one, is 7.9. So it's higher or is bigger than 1.5 IQR starting from Q3. So this is an outlier. So that is the first one. We cannot stop here because the first one is an outlier, then the second one may also be. So we try this one here. And this one, after some calculation, we found that this one is not. So this one is, okay, so this one is outlier, but this one is good. This one is not outlier because it is 6.1 is something here. It's less than 1.5 IQR from Q3. So this one is not outlier. If this one is not outlier, then all others cannot be outlier. So then we stop at this point. So in this example, we have only one outlier, which is 7.9. Right now we are discussing the spread. The spread is represented by this these numbers. Can be represented by a 5-number summary, and also a more typical method to represent the spread is called standard deviation. Standard deviation is very important. Here is the definition, and we use this example to show how to understand and how to calculate standard deviation. In this example, we have several numbers. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Suppose we have 10 numbers. Right? We sort these numbers from smaller to in increasing order. The minimum is maybe 59. Okay, the next one is 60. Okay, 61. Okay, 62, 63, and 64, all the way up to 68. Right? These numbers are integers. And we are going to calculate the mean. Right? The mean is add all this together, then divide by 10, and it looks like the mean is right here. Right? Now we can see all these numbers are different, and this number has difference between itself to the mean. So this is this difference, and for this number, this is the difference. This difference, and for the top half, this difference will be positive. Use this number minus the mean, this number minus mean minus difference. Right? So we can see we have all these differences will not be equal to 0. Right? We can guess if a data set has large variations, then these differences will be large, either very large positive or is very large in the negative side. If they are almost the same, they are around here, then we can guess the variance is small. But we cannot add all these variances directly together. If we, in this example, all these are positive difference, all these are negative difference. If we add them together, this example is special. So this one will cancel this, this one will cancel this. So this one will cancel this. So it looks like we are going to get a 0. If we add all these differences together, we are going to get a 0. That means the variance looks like equal 0. That means there's no variance. All the numbers equal 63.5. We know that is not true. So what we do is, instead of add this difference directly, we are going to add the difference squared. So here, for each number minus the mean, give us the differences. Then we square this, differences, then square. Now all the numbers will be positive or 0. Then we add them together. Then we divide it by n minus 1. N is the total number. In this example, n equals 10. So this sum will be divided by 9, and this gives us the variance. The variance is represented by s squared. Standard deviation is just s instead of s squared. S squared is the variance. Variance is s squared. The s is called the standard deviation. The standard deviation f is just the square root of this part here. Now we have something to be careful. The first one, this n minus 1. Why? You may ask, why we do not divide it by n? This n minus 1 is called the degree of freedom of the variance or standard deviation. The degree of freedom, that means in this example, n minus 1 equals 9. That means we can only have 9 freely changed numbers. Not all these 10 numbers can be freely changed. The reason is because for this mean, all the difference add up together must be equal to 0. for example, in the class, midterm class, everybody has a score. If we have the highest can be 100, the lowest can be like 60, for example. And if we know the mean equals 85, then each number, each score minus 85, either positive or equals negative or equals 0. But all these differences add up together must be equal to 0. That is the meaning of the average. So that means all these differences add up together equal to 0. So for example, we have this 10 differences add up together equals 0. That is a limit. Those are all constraint, all condition. Then only 9 of them can change freely. The last one cannot change freely. Because this is restricted by the condition that all the sums must be equal to 0. For example, I said we have 3 numbers, n equals 3. And you choose any numbers, but there's a condition that the sum of all these numbers must be equal to 0. So I said I choose the first one freely, okay, equals 10. Then the next one I change freely equals 5. Now the third one you cannot change freely because you need to satisfy the condition that the sum of all these 3 must be equal to 0. So the third one is not, you cannot change, you cannot choose freely. The third one must be equal to negative 15. So we add all these 3 together equal to 0. So the degree of freedom equals 3 minus 1 equals 2. You can choose only 2 freely. So that is the meaning of degree of freedom. As the standard deviation measures the spread about the mean. If f equals 0, that means the standard deviation equals 0, or the variance equals 0, that means there's no variance. That means there's no spread. All the numbers must be the same. S is not resistant to outliers. That is easy to understand. The reason is S is calculated from the mean instead of the median. And we know the mean is not resistant to outliers. So that's why F is also not resistant to the outliers. What does that mean? That means if you have a number is an outlier, for example, this number is instead of 60, then the number is if this number is very changed, changed a lot. For example, this number here, you change this number as if this number here changed a lot here, then we know the variance, the standard deviation will change a lot. So that's it is not resistant to outliers. Okay. Now we have an example to show how to calculate the mean and the standard deviation. We are given a data set represented by x. The data are given like 1, 3, 5, 4, 6, 3, 6, 3, 5, and 4. Step 1, if we look at the formula for standard deviation, we need to know the mean here. So the step 1 is to calculate the mean of the data set. The mean is the sum. To calculate the mean, we do not need to sort this number. So we just add everything together. So 1 plus 3 plus 5 plus 4 plus 6, all the way up to 5 and 4. We add together. We divide it. Keep in mind, when we calculate the mean, the divisor must be the total number, not n, not n minus 1. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers. So divided by 10. And the sum equals 40 and divided by 10, so the mean x bar equals 4. The next one, if we again look at this one here, we need to subtract this mean from each data, then take the square, then sum up together, then divide it by this example divide by 9, then take the square root. So here, I list all the numbers x here equals 1, 3, 5, 4, 6, 3 all the way to 5, 4, and each data minus the mean. This one minus 4 equals negative 3. This one minus 4 equals negative 1. This one minus 4 equals 1. 4 minus 4 equals 0, and so on. We calculate the last one, 4 minus 4 equals 0. So this is the difference. Then the difference is square. Negative 3 squared equals 9. Negative 1 squared equals 1. 1 squared equals 1, 0, 0, and all the way to here. The next step is to calculate the variance, means we add all these positive or 0 numbers together. So 9 plus 1 plus 1 plus all this up to plus 1. Then divided by here. We need to be careful. This one must be, this one. Okay. I think this one is the we need to divide it by this one, n minus 1, so divide by 9. So the sum equals 22, and divide by 9 equals this. We don't need to calculate this because we are not interested in variance in this example. Instead, we are looking for the standard deviation. So the standard deviation equals the square root of 22 over 9, and you use your calculator to calculate this one, equals 1.5635. Some of you may ask what kind of calculator we can use for the homework or for the test. We do not have any requirement for this, but I know some complicated calculators have a function, and you can directly plug into these numbers, then it automatically gives you the standard deviation and all the everything else. But that is not what we are going to use. If you do this, you only give me this number here, you get nothing, you get no credit. What I want is you need to follow these steps. I give you a data set, you said, okay, first one, we calculate the sum. Okay, you can use the calculator to calculate the sum must be equals this. Then calculate the mean. I don't want you to just use one key. Okay, so the mean equals 4, the standard deviation equals 1.56. We are going to, because the data I give you is very simple. So you just punch into your calculator and try to understand the steps, the procedures, how to calculate this. We want you to understand the concept, not just use the calculator to do some special functions to do this. Definitely in the test or in the homework, I won't give you a numbers like 100 or 200 numbers. It takes you a lot of time. We don't do that. We just try to understand the concept. So this is more important to our class. All right, the next one is the linear transformation of data. Many of you deal with data. For example, if you're doing a chemical experiment, you may want to change the unit. If you deal with the materials, you want to deal with temperature. Sometimes you want to change the unit of temperature. You want to use the Fahrenheit, you want to use the Celsius, or no matter what, we are going to change the unit. So, a linear transformation is defined by, first one we have the original variable, the x, then the transformated variable is called x new, or sometimes we call y, it doesn't matter. We multiply the original data by a constant b. Keep in mind b here, both b and a must be constant, cannot be a variable. So multiply by the constant b, then add another constant to it. If any transformation satisfies this condition, multiply the increase or decrease by some ratio, then add to a shift, add a positive or negative number. This is called a linear transformation. Okay? We can see if we only multiply by b, if b is larger than 1, then this one will increase the variable. Right? We can add a. If a is positive, that means we move the data upward. If a is smaller, is negative number, then that means we move all the values, shift all the values downward. Linear transformation does not change the shape of the distribution. So for example, if you have a data set X, the shape is the distribution shape looks like this, right? Look like this. Then if you do this linear transformation, right? For every X you multiply by some number, then add to a constant, or A and B must be the constant. Then after the transformation, the new variable also has a distribution with this similar shape, cannot be anything else. Right? So that is the property of a linear transformation. If we have a multiplication only, that means this one here equals 0, we have only this b. For example, b equals 2, equals 3, or equals anything else. Right? Then the measure of the center, which means we discussed the mean or the median, and the measure of the spread. The spread is RQR, this, and the standard deviation S are all multiplied by B. Okay? Later time we are going to use the example to show how to do this. If we have addition only, that means this B is 1. We don't have this B, not B equals 0, this means B equals 1. So just the number multiply, add to a constant A, then the measure of the center and the percentiles are added by A, but the measure of the spread will keep constant. Okay. Next one we have an example to show how to start this. Alright, so here Fahrenheit is a thermodynamic temperature scale. We do not want to discuss the details here, but we know Fahrenheit is related to Celsius by this. If Celsius degree, then multiplied by 1.8, then added by 32, that gives us the Fahrenheit. For example, if the Celsius equals 10 degrees Celsius, then 10 times 1.8 equals 18, then plus 32 equals 50. So 50. Now the room temperature is maybe 70, for example, 77. Right? If 77, then that means this one equals 77, then minus this will be equals 45. Then 45 divided by 1.8, it will give us, this C will be 25 degrees Celsius. So 25 degrees Celsius will be equal to 77 degrees Fahrenheit. But anyway, this, look at this, F equals 32 plus 1.8 times C. So obviously this is a linear transformation. To transform from C to F, A equals 32, B equals 1.8. Sometimes we want to transform from F to C. Then we can rewrite this formula as C equals this, F minus 32. So F equals minus 32, then divided by 1.8. So it will be negative 32 divided by 1.8, then plus 1.8 here, and that's F here. Right? These two formulas are equivalent. From here, if we convert F into C, this is also linear transformation. So A equals this, and B equals 1 over 1.8. But anyway, the conversion between C and F is a linear transformation. So here, we have, as we said, for linear transformation, the distributions will have the same shape. And in this example, the red shape is the Celsius, and the blue one is the Fahrenheit. So both have the same bell-shaped, and they may have a different center. For this red one, the center equals 0, right? Okay, so we can see the center equals 0. For this blue one, the center will be equal to here, so it looks like equals 32. And they have different spread. Right? This spread is the standard deviation, maybe this, but this one standard deviation may be this. So obviously, in this example, the standard deviation of F will be larger than the standard deviation for the C. Okay, this is the example one. Now we have another example, and this one is just we investigate this from this roughly from this figure. The next one we are going to calculate something. Right? So here, linear transformation example 2. Suppose you get some score. This score is called the raw score, and we are going to have a curved score. The curved score y is related to the raw scores x by this y curved equals 1.2 times the raw score, then plus 20. Again, this is linear transformation. In this example, a equals 20, b equals 1.2. Both are constant. So suppose the mean and the standard deviation for the raw scores are the mean equals 50, the standard deviation equals 10. What we are looking for is what is the mean and the standard deviation of the curved score. So I'll give you the information here. I'll let you think about a little bit, a few seconds, how to calculate what is the mean of the transformed score? And what is the standard deviation of the transformed, the curved scores? If we look at here, and we said, in this example, we have both multiplication and addition. If for multiplication only, the center, which is the mean, the center will be multiplied by b, and for addition, the center also be added by a. So from here, we get a hint: the mean or the center of the curved score must be multiplied by this b, then added by a. So that means y bar will be equal to the original mean 50 times 1.2, so give us 60, then add to this 8. 10. So this one must be equal to, this one will be equals 80. Okay. How about the standard deviation? The standard deviation means the variance of the data. The 20 here, this constant does not have any effect to the standard deviation because everybody is added by 20 scores, or then all the variance will be the same. But this scaling factor 1.2, this constant b will change the spread, will increase the spread here. So this standard deviation y will be equal to the original standard deviation 10 multiplied by 1.2. So this one will be equals 12. Right, so this is 80, this is 12. How about the median and the interquartile of the curved score? The median is, okay, I write here, so this equals 80, this is 12. And the median is another measure of the center. And we know the center will be affected by both A and B. Right? So the median will be multiplied by 1.2, then added by 20. Although we are not given the median here, but just let you think about this. So the median must be multiplied by multiplied by B, then plus A. How about the interquartile? For example, IQR. What is the IQR? The IQR is another type of the spread, which is very similar to the standard deviation. So if every data is added by 20, that IQR won't change. But if every data is multiplied by 1.2, that will affect the IQR. Just very similar to this standard deviation. So we see the interquartile will also be multiplied by 1.2, but not added by 20.